Hi everyone, this is Miss Englert. These are your notes for Monday, March 1st or Tuesday, March 2nd, 2021. What is eccentricity and how do we measure it? So for this first one, you're going to draw the shape of Earth's orbit around the sun. So Earth's orbit around the sun, I'm going to go ahead and draw that shape for you do now. So a little bit of vocab for us. Our first vocabulary word is ellipse. So an ellipse is an oval. It's like the shape of an oval. And we can further define that as an oval is an elongated circle with two centers called foci. Another word for elongated can be stretched, if you know that word better. So on the shape, we have an elongated circle, and then we have two centers, one there, and those are called foci. So one focus, or plural, if we have more than we have foci, they are central points of an ellipse. And in our solar system, orbits around the sun are not circular, they're actually elliptical. So the sun in our solar system is going to be one of these foci, and it is located, and it is always located at one of the foci. So our next vocabulary word is going to be the major axis. And the major axis, as you can see, is this line. I'm going to go ahead and highlight it for you. This long line is the major axis. It is the longest straight line that you can draw through an ellipse. So you can draw plenty of other lines. You can draw a line like this, or this, or this, but that pink line is going to be the longest line, and that is our major axis. Our major axis actually passes through both foci. So eccentricity is the degree of flatness. So how flat or ovalness, these are totally made up words. So if you were to take it down, a level is, if it is flatter, it's going to be more eccentric. If it is less flat, so if it is rounder, it's going to be less eccentric. One word for you guys to know is eccentric. And you guys may have heard this in the terms of like, you have an eccentric aunt, which means that they might, like, people who are eccentric, you hear of like eccentric billionaires. They buy strange things, or what some people might label as exotic. So like Tiger King. The Tiger King is totally eccentric, like kind of doesn't fit in the same circle as everybody else. So they're just a little bit stretched. So eccentricity ranges between 0 and 1. The only possible values for eccentricity are between 0 and 1. So if the eccentricity is closer to 0, it is less eccentric. So the more eccentric something is, the more oval-shaped it is. If the eccentricity of a planet or other object is close to 0, the orbit is less eccentric, and it is closer to a perfect circle. If eccentricity is closer to 1, that means that the orbit is more eccentric, which is more oval-like, and that means that the orbit is more elliptical. So more eccentric equals more elliptical. Less eccentric equals less elliptical. So you can go ahead and label there's less and then more. So this is closer to 0. And it can go up to 1, which is a perfectly straight line. So a couple phases you need to know in the Earth's orbit. This first one is the perihelion. And this is the point in the orbit where the sun, or rather where the Earth is closest to the sun. So when I think of perihelion, I think of my cats. Because cats purr, and my cats always want to be close to me. They're very needy. So perihelion, think purr, think close to me. So when the Earth is at its perihelion, so when it is nearest to the sun, it has more gravitational attraction to the sun, and the planet actually moves faster in its orbit. So one fun fact about the perihelion, this is actually the perihelion right here. But the Earth is not that large and not to scale. This is on my end. This is actually a GIF and it is moving around. We'll label this Earth on the other spot. So this is the perihelion, and this is when Earth is closest to the sun. And something that may surprise you or seem strange to you is that the Earth is actually closest to the sun on January 3rd. So on January 3rd, when we were all freezing our butts off this year, we were actually closest to the sun. The other point in Earth's orbit, which we're going to talk about, and this one is correctly labeled on here, this is our aphelion. And this is the point in Earth's orbit where it is farthest from the sun. And the way that I remember this one is F. If you just say that part, F sounds like the beginning of a sneeze, and people are disgusting. So if you're at the aphelion, imagine it's somebody sneezing like that. You want them as far away as possible. So if somebody is sneezing, you want them far away. If the Earth is at the aphelion, it is far away from the sun. And at this point, we have less gravitational attraction. The planet actually moves slower because the pull from the sun is not as great. And during the aphelion, the Earth is actually farthest away. We use far instead of further, so farther instead of farther because we can actually measure the distance. Use further when it's like metaphorical, like you can't be further from the truth. You can't really measure that, but you can measure how far away the Earth is from the sun, and it is actually farthest from the sun on July 4th. It is farthest away from the sun. All right, so on this one, it's actually an animated GIF that you can see there are different ranges. This is if the eccentricity were 8. Oh, I can't draw on this anyways. So please enjoy this picture of an ellipse that says 0.8 eccentricity. Okay, so the way that we can calculate eccentricity is using this formula, and this is actually on page 1. Page 1 of your Earth Science Reference Table. It is this equation, so go ahead and circle that when you are on your own Pear Deck. And so what you can see is eccentricity is the distance between the foci. So these guys, that's one focus and that's one focus. Together they are foci. So you would take this distance. So this is going to be D. And then you're going to take the length of the major axis. So it would be from this point here to this point. If you were to draw that straight line, you would measure those two distances. So because it's d over 1, so imagine that this is this whole thing is 1. So let's say that this whole distance is like 1 centimeter. D is going to be something smaller than 1 centimeter. So it can be like 0.5 centimeters, it could be 0.6 centimeters. You would take whatever that number is, and it would be D over L. So the distance between the foci, hang on, I had this lowercase. So distance between foci over the length of the major axis, and that's going to give you eccentricity. Okay, so there is just this slide. Since Earth has an elliptical orbit, the distance between the Sun and Earth varies. 2, the distance between the Sun and the other focus varies. 3, the distance between Earth's major axis varies. Or 4, the length of Earth's revolution varies. And then go check out Google Classroom for your quiz to make sure you got all this information. Good job, guys.